Hi, my name is Pavel Cherkashin. I run a venture fund in San Francisco called GVA Capital. So I run a venture fund. We have about 120 million under management. We're a more traditional venture fund, but we started investing in crypto projects. Recently, we were the first equity investor in Storj and several other projects. We also now we just invested in a big project related to putting advertising exchange on blockchain, and that requires not 10,000 transactions per second, but that requires at least 1 million transactions per second. And in the near future, to be competitive, it should be 10 million transactions per second. So we're going to discuss later how we're going to do this, right?
Sure. Yeah. Should I go ahead?
Sure. So you can add something to the point?
Sure. Hi, everybody. My name is Chris Dannon. I'm a founder and partner at Iterative Capital Management here in New York. We're an alternative investment manager with about $20 million of crypto under management, and we also operate a large-scale mining facility here in the Northeast United States. We're backed by one of the largest family offices. So that's us.
My name is Nelson Hunter Prendergast. I am the CTO of Mimir Blockchain Solutions. We're a company that's working on actually a scalability solution for the Ethereum blockchain specifically that could be extended to any other blockchain that utilizes smart contract logic. I'm a computer engineer and former nuclear reactor operator, as well as a renewable systems engineer.
Tom Bullock. I am not a nuclear scientist. CTO of MadHive, is also a co-founder of Zynga, was CTO of Zynga. And we're also doing an ad tech, but we're a running ad tech company for over a year now. So.
I'm Joseph Bonneau. I'm a computer science professor at NYU. So I guess not looking to buy or sell anything, except everybody should buy my textbook. But anyway, I mean, my background's cryptography. So I've been interested in blockchains for quite a while now, and interested in sort of reasoning sort of theoretically about the limits and what we can and can't do with blockchains.
So let's share your insights about technology development. So what is needed to be changed in blockchain? What protocols have a best technology potential?
Sure. So we were just debating this off stage. I mean, one of the things we were talking about is the consensus algorithms. Trying to take a generic consensus algorithm to all blockchain, or without the context of what the blockchain is trying to do, is probably one of the biggest gating factors in speed today. Which is why for us, we're basically interoperating with different sets of blockchains from different families to do different things. So because our main goal is to build a distributed ad server. Because at the end of the day, you want something distributed that no one owns, controlling who gets paid what, right? So how do you do tens of thousands, hundreds of thousands transactions per second? What we're coming out with is essentially proof of real work, or proof of utility. So the idea is, you have something. In its essence, proof of work has 3 criteria, right? You have an action that's it's hard to do, it's easy to verify, and you have a mechanism to make it harder. So doing within the context of what you're trying to do in your blockchain is breaking down the utility to fit within that pattern. Is one of the big ways of trying to speed everything up.
I'm sorry, I'm not an engineer, right? I'm more on the buy side of this conversation. But as far as I understand, correct me if I'm wrong, there are 3 main ways to go. To improve the the speed of the algorithms within the blockchain, to put some of the data somewhere outside on a proprietary system, like Lightning, and then just keep the the.
Well, let's be clear. Like when you say go outside, that means bypass the consensus algorithm.
Yeah,
Right.
yeah.
It can.
Or-
Some
yeah.
protocols maintain cryptographic security even through sidechain utilization.
Yeah.
So, granted, you sacrifice liquidity to do that.
Before you jump in, and then the third way is to do some sort of sharding or partitioning where you put different kinds of data into different blockchains and then do a magic
Right.
on top of
but
that.
everything you're saying gets you to like 2,000 QPS. Like, how do you get to 100,000 QPS? Queries per second.
If you put million blockchains one on top of the other and have them
Yeah, but you start
have
losing
separate consensus.
efficiency with number of shards, though. Right. So I mean, it's I can tell you from Zynga, we had 100 million concurrents all trying to pet pigs. Like, let me tell you, it's like we were 70% of all of AWS at one point. So I mean, it's a massive scaling problem, but sharding only takes you so far.
So, obviously, within sharding, the other thing that has come up is Plasma within the Ethereum network, which is a mechanism to essentially do a variant of sharding with Merkle proofs and essentially tree-structured side chains. But as you were saying, the complexity as the depth of that tree grows means that the ability to interact between smart contract logic that is persistent on two independent shards makes the computation much more difficult.
Right.
So it's the sacrifice of speed or accessibility or additional complexity. You always have to give something up to gain something else.
Right.
So,
But do you understand correctly that it's only required if you want to have a single consensus among all of them, right? What if you don't require this consensus? What if you have, let's say, 5 or 10 or 100 or million blockchains, each with its own consensus? Does this make any sense to you?
Professor?
Maybe. The problem with that's equivalent to having shards with a hard requirement that you can never communicate across shards, which, I don't know. I mean, usually one of the goals of most applications for blockchains is kind of everybody in the world can interact, and we won't have siloed currencies that don't talk to each other, so...
Well, through projects like Polkadot, though, you can interop between chains, though.
But what's the alternative is to go over the counter through a human being or a trusted counterparty, which people do a lot already. And now with the CME trading futures, they'll have no problem with this. So I'm just curious if you guys think one will develop quicker than the other.
Well, I mean, our goal, so at MadHive, what we did is we developed a centralized ad server. We're already...
I see many signs that we should speak louder.
All right. So at MadHive, we created a centralized ad server that already handles hundreds of millions of requests per month. So the idea is we're building our own competition, but on the blockchain. So we're moving small pieces at a time from the centralized system to the decentralized system, in the hopes of fully being decentralized in like the next 5 to 6 years.
So what's your bet? What would you bet on when, let's say you have somebody with a gun to your head asking, I'm sorry, I just watched a startup TV series last night.
I'm in a startup, so there's always a gun to our head.
Yeah.
Yes.
So what if, what if they come and they say you need to build a solution to put 100,000 transactions per second in the next 6 months? What are you going to do?
Well, what kind of transactions are they?
Yeah.
This matters a lot. If it's all simple payments, then there's some stuff we might know how to do. If you want sort of arbitrary smart contract functionality, then much more difficult to scale to a lot of transactions.
Let's say simple transactions to make it simple.
Well, you could probably do that today.
Just record.
Just payments?
just record the data. Whatever, let's say the ad server, and you need to record all the data, all the clicks happening on the system, on the ad server, and all the transactions.
So you just need to commit to data and you don't have to do any computation or validation?
Like proof of stake is, some version of proof of stake is usually will get you there with sharding. Like you can do that today and probably get to 100,000.
I believe last time I looked at the specifications,
Louder, please. Yeah.
Last time I looked at the specifications, Tendermint on a consortium chain was in the tens of thousands of transactional validations on a single validating node per second. So obviously the simple solution is to go with centralization, but that's not the solution that the community wants. It's not the solution that is optimal, because centralization essentially removes a lot of the very security that the blockchain creates in the first place. So you have to ask what level of compromise you're willing to accept. Are we giving up security for speed? And is that an acceptable compromise in the application that you're looking at? It may be within advertising because the cost of any given interaction is essentially fractions of a penny. It may not be, but that's really the determinant is the end users. If they're willing to accept that compromise for that utility, then that is absolutely the correct method for a temporary holdover. I would say that the ideal solution is definitely decentralized in nature, though.
What he said.
All right, so I'll be a contrarian. So maybe that's the solution for the most liquid coins, for Bitcoin and Ether, but it's very difficult to get the long tail of coins listed on these exchanges because they essentially do business with just anybody and not much KYC AML information. Whereas accredited people who go over the counter with a broker-dealer or someone equivalent, those broker-dealers take a lot of information and are responsible for what they sell and to whom they sell. So I'm just curious, like that future seems viable for the biggest, most liquid coins, but what about everything else?
Well, the MAD token isn't necessarily a large coin, right? Like are you asking like how do we technologically get there, or how do we convince exchanges to list us?
Given that the exchanges, the way that they're...
FYI, I believe exchanges are one of the biggest dangers to blockchain because they undo the decentralization, like being centralized entities that control gates.
Sure, but they also bring liquidity into the system, and if we want to use these things in production settings, I think it's incumbent on us to either use things that have been cleared by regulators like Bitcoin and Ether, which Gemini trades for US dollars, and everybody's okay with that.
In the US, but not in China, but
sure,
which is your biggest market.
Yeah, I'm just saying there's a regulatory component here which may affect what can be developed or is practical to develop.
What would you like to replace exchanges with?
Well, I mean, okay, so Stellar is a great example, right? You can do an ICO on Stellar, and they have a decentralized exchange built into it. So if you do an ICO on their chain as opposed to Ethereum, you're automatically in the exchange.
But
which
only
is decentralized.
Only with other Stellar coins, though, right?
No.
Okay, so you can
swap use other coins in Stellar.
Do they have atomic swaps?
Yes.
Okay, so then...
Okay.
How does the decentralized exchange actually sort of absorb fiat currency or whatever consumers want to actually buy into the system with?
Well, so there's ingress and egress points to crypto, right? So Gemini and Coinbase are like the ingress and egress of tokens, but not necessarily what you trade on all the time. Because then you take your Bitcoin to Bittrex, and then you go for the interesting stuff.
So you mentioned kind of swap for exchanges. This means that tokens are exchanged without custody,
So atomic swaps are a mechanism to cause an exchange of value to occur between two different chains. There's multiple ways to facilitate these interactions. A lot of it involves essentially cryptographic proofs or some intermediary party that's willing to act as an escrow mechanism. More recently, smart contracts acting in escrow is the preferential mechanism because it's a trustworthy third party essentially. And this is something that is still being developed and put into production environments for really mainstream use, but it has a large potential to increase liquidity and the ability to do different things, move between markets more seamlessly.
It's the future.
Yeah.
So how does that work in terms of collateral requirements on the different chains? I mean, is there any possibility that at scale, if all the chains are using atomic swaps, assuming that we know how to match orders, which I don't think that accounts for, but is there a risk that there's too much that is bound up in collateral and the system's not very liquid?
Oh, I mean, I would
Yes.
say, yeah. This is one of the considerations with the RAIDEN network. That was one of the original criticisms, was this very comment, was assuring liquidity and balance within the pipes. And it's a problem that they are actively addressing within that project. But I haven't seen the mathematics that actually prove the solution they're claiming yet, so I don't know. This is one of the big pending problems, is if you're going to use side channels or mediated third parties, how do you keep them balanced, fair, and non-destructive? Yeah.
So what about AirSwap and Bancor? Does it work?
Who?
Bancor.
Oh, Bancor? I would assume so. Like I don't know much about Bancor. I believe Bancor, Stellar, there's like 2 or 3 others. They're all kind of in the same boat. That you essentially can launch other coins on top of.
Wasn't there just the Google engineer that figured out how to front run Bancor?
Yeah.
So I guess that's only in a context where you're using an Ethereum smart contract. Presumably if we're using side chains, those are not transparent, right? They're like dark pools.
Depends on the construction, but with the recent updates that went into the Ethereum protocol, ZK snarks, or at least the fundamental primitives of ZK snarks, these are zero knowledge proof mechanisms that enable you to have anonymity in an exchange of value, were actually implemented in Ethereum. So you probably could have variants that were transparent and variants that were obfuscated as well. It depends on what your application is.
So, what about costs of protection from hackers? It's proof of work, proof of stake, proof of asset. What is the most perspective way to solve this problem of hacking by devoting a lot of resources for mining blocks?
What was the last one you said? Proof of?
Proof of asset.
Of asset?
Professor?
Okay.
So how do we move from proof of work to proof of stake?
Yeah. So the short answer is we don't know, and anybody who says they know is being very overconfident about the theory. I mean, we don't really have any kind of formal model in which we can prove that even that Bitcoin with proof of work is actually a stable consensus protocol that's anything close to reality. You have to make so many assumptions in your model to start arguing that some incentive compatibility property holds in Bitcoin that we know it's like a extreme approximation of reality. To argue about proof of stake, you have to add a bunch of extra assumptions on top of that. And we also don't know how...
A lot of letters.
What?
A lot of letters.
Yeah, and we don't really know how realistic any of those assumptions are either.
Because correct me, like proof of work is the only one that has been proven to date that no one has hacked. Because there's $100 billion worth of value in Bitcoin that is, it's kind of sitting on the table if someone can get to it.
So, I mean, I guess usually we would call that like experience rather than proof. And there's definitely a lot more experience behind proof of work. That's promising. It's held up okay with a large amount of value. But again, we don't really know, like, is there some property of reality right now that's going to change, like when, a simple example, when the block reward starts to dwindle and Bitcoin switches to an entirely fee-based model, the whole thing might destabilize. There's some theory papers that say the incentives really change, and we don't really know if it's stable at that point. And there could be other sort of honeymoon properties about the fact that the system's relatively new that have sort of kept it going. So we have some great experience, which is good, and for that reason I would say we have the most confidence in proof of work right now. everything else requires additional assumptions that we just don't really know. We don't have a good model for. I'm kind of a pessimist that we'll ever have a good model for. But in any case, like eventually we'll find out one way or another through experience. But I would sort of caution people against. There's kind of a desire to switch to some proof of stake model, and people say, oh, there's some formal proof that it's secure, so everything's going to be okay. But those proofs are always just a reduction of certain properties will hold if a certain set of assumptions are true. So the fact that a proof exists doesn't really mean anything depending on what the assumptions are. All of the assumptions are sort of up in the air right now. So the long answer is also we don't really know.
Definite maybe.
But it doesn't mean that it's not worth trying, right?
No, absolutely not. I mean, it's a totally worthwhile thing to try. I just think that in practice, like our confidence that proof of work is stable. It's sort of slowly grown over time with experience. It didn't come, the day the white paper was written from it being proven mathematically. So I'd sort of caution against the fact that we'll know that any proof of stake protocol is viable just by reading a white paper and having smart people look at it. We're really only going to know after it's been running for 5 or 10 years and has been robust kind of across a wide range of conditions, and we'll start to have more confidence. So I think it's sort of better. I think it's much wiser to start small with proof of stake and sort of slowly build value over time rather than say try to switch a very high value system already over to proof of stake.
Well, I think that the inevitable resultant would be if you were to take, say, the Ethereum network and instantaneously modify it to be a proof of stake mechanism, you would have a lack of majority, or the miners would essentially revolt because all of the investment in the asset that they have is tied up, and it's non-trivial investment. So I think that definitely any transition into a proof of stake mechanism is going to be one that you have to do incrementally. Insofar as the securities of proof of stake, I can say that the solution that my company has been working on utilizes a proof of stake mechanism underneath, and it was very non-trivial to demonstrate the Nash equilibriums, to demonstrate the balance of the system and build all of the game models. And every time you think that you've got all of the circumstances covered, there's always another one that you have to go back and double check your assumptions against. And it is not an easy task to build one that will actually work. It takes a lot of hard work and a lot of people looking at the same problem many different ways and asking, are all players rational? Are all players balanced? Are players pure greedy? I mean, what set of assumptions, as you said earlier, do you make for the system? And I think the best answer we can give is that, at least within the formulation we worked on, was so long as we can demonstrate that the probability of an economic advantage or a benefit coming from cheating the system is so minute that it was never within the probability of success for the player, that was at least the first step to having a valid system. But there's a lot of other things that have to go into it beyond just that. Not everyone is rational.
Actually, Ethereum is presenting their proof of stake today at DEF CON.
Yeah.
So, TBD.
Yeah, absolutely.
Great. So I think that there might be a lot of questions about this, all of this.
There was one that wasn't mentioned that I kind of had some questions about, because I know that it's being used more in the Hyperledger, like decentralized Hyperledger with Sawtooth, and that's proof of elapsed time. What are your feelings on proof of elapsed time, and do you think you'll find that more in the permissionless kind of systems for blockchain as well?
I love it if it works. Like the idea of it is fantastic, and it's very little energy, right? It's extremely small energy, and I think one of the big problems was there was something in the Intel chip that made it so you could do it. So I'm not sure if that's acceptable, to the blockchain at large.
Yeah, so I guess I can follow up and say maybe why I don't love it, which is it relies on trusted hardware, this trusted execution environment, and Intel, I believe, is the first company to get it to market, and some other chip makers are having their own versions. But it's sort of fragile if those chips get if those chips get hacked, if there's kind of this signing key from Intel that gets stolen, then you can sort of instantly create the appearance of a huge amount of mining power out of nowhere, and the system would collapse. So compared to other systems, there's kind of like a big vulnerability to catastrophic failure. So that really worries me about that system.
Or not.
As a tangential follow-up, one of the interesting things that's coming out is TrueBit. Have you seen the paper? Essentially the concept of proof of computation, so using zero-knowledge proofs or other forms of proof, such as Merkle trees, to construct proof that you've actually done work by a specification. There may be some mechanism for software-driven equivalence. There may not, but at least something to keep your eye on and be aware of is proof of computation, and it may facilitate those types of actions in the future. I don't know, no promises, but that's something to look at.
Thank you.